Okay, we're back again, and since we're presenting this within the framework of TrainMoS, reference to modal shift is relevant as it relates to the motorways of the seas, and we have a modal shift exercise for Greece. In the case of comparing short sea shipping with the road alternative, and this is for the transport of freight. This is what we're aiming to promote in short sea shipping, providing a more sustainable mode of freight transport, especially with regard to the road-borne freight. But in doing that, short sea shipping and motorways of the sea schemes must demonstrate that they are superior in their competition with other freight transport modes, not only with regard to commercial viability, but in other terms as well, as we expect to have greater benefits, especially when we refer to negative externalities. So this is what we concentrate when we carry on an exercise of this type. The compared freight services is a road freight between Athens and Thessaloniki, and the alternative of involves the short sea shipping freight, which has a sea leg connecting the port of Lavrio with the port of Thessaloniki with a Roros vessel, and it would be necessary as well, in order to complete the short sea shipping mode, to have a smaller road leg connection between the Athens Freight Center and the port of Lavrio, which is serviced by trucks. A couple of points with regard to this comparison here. Of course, most of short sea shipping schemes are destined to provide longer connections, and within the European framework, what we look as well is to be able to provide connections between neighboring countries. In other words, beyond the ports of a single member state. But and we do expect such a connection to give us better results than over a longer distance than what we're looking at right now. But as an example and as an exercise, it will demonstrate the way we can approach things in terms of internal costs of the services and external costs of the services, which is what we are interested in assessing and comparing the two competing freight services. The short sea shipping freight service as I said, it includes a sea leg between Lavrio and Thessaloniki, and this is performed through the operation of a Ro-Ro vessel, which has vessel characteristics as shown in this table. single vessel operating daily, performing one round trip. The sailing distance is nearly 450 nautical miles, and the sailing time for a service speed of 25 knots, which is quite a high speed, but we would like it to be able to accommodate this distance within this time frame. On a round-trip basis, it will take about 18 hours. Port turnaround time is nearly 3 hours. It operates 335 days per year and presents an average ro-ro vessel utilization of 62.5%. It is considered appropriate, although we will see whether any changes on that will influence either internal externality, mainly in the total costs. Internal externality, internal costs, external costs, and the total costs of the services. Now, on this basis, the sea service will have to involve the road leg between the Athens Trade Center and Lavrio, performed by trucks, and the number of trucks which operate, we assume there will be 50, and they will do 4 daily round trips back and from the freight center and the port of Lavrio. There's a driving distance near over 140 kilometers, and on the basis of an average speed of 55 kilometers an hour, to include to take into account the fact that we're not moving on a motorway throughout this distance. The driving time will be about 2.5 hours. We need a port and turnaround time of 1 hour, and it will equally operate this movement of freight between Athens and Lavrio on the road for a period of 335 days, which corresponds to the operating days of the ro-ro vessel as well. Now, this implies that the vessel will be carrying 200 trucks per trip, not per round trip, but in every one-way movement. So that constitutes, that gives us, corresponds to the utilization of 62.5%. As a fact, this represents something of the order of 50% what is currently moving in terms of freight, container freight, between Athens and Thessaloniki via the road on a daily basis. Nearly 400 trucks are covering this distance on a daily basis. With regard to the road freight, some more details, we saw it before. The trucks are identical. The engine power is 365 kilowatts, and we have an average speed for the road service here between Athens, the Athens Trade Center, and Thessaloniki of 80 kilometers per hour, and that of course is much higher because we're moving along the 85 motorway which will give us the ability to have higher speeds than the other connection between Athens and Lavrio. Number of tracks to 100, number of daily round trips 1, driving distance of the order of 1,000 kilometers, driving time 12.6 hours for the speed we're quoting here of 80 kilometers per hour, turnaround time of half an hour, and again the duration of annual operation has to correspond with that of the short sea shipping service. Now, for having an estimation of the internal cost for the RoRo service, we have to take account of the fixed annual costs of vessel operation, which include the purchase of the vessel, the crew, vessel's insurance, administration costs, which would be everything else included in those that item, and also the variable annual cost of vessel operation, which will definitely include maintenance and repair for the vessel, and the fuel, lubricants, port dues, and something also has to be done with regard to the truck services, whether the truck services involve the movement of the freight along the Thessaloniki Athens motorway, or the connection between Athens and Lavrio. Of course, different numbers will be included, but in terms of the items which will have to be accounted for, we have fixed annual costs of truck operation, which will have to include capital costs involved in the investment of the trucks themselves, purchase of the trucks, driver costs, vehicles insurance, administration, which is MOT, road taxes, whatever else we can include under this regime. When we say driver costs as well, we're talking in terms of salaries, insurance, personal health insurance, and contributions, and items like that. Okay, and with regard to the variable annual cost of truck operation, more or less similar things, just like we had with the vessel: maintenance and repair, fuel, lubricants, road tolls instead of port dues in this case will have to be considered. Now, in order to be as more detailed as possible, in order to facilitate the reliability of the estimation, an activity methodology is best way to go about it, and in this case we have to talk in terms of, for example, with regard to the fuel costs, we have to cater for, with reference to the the fuel costs at sea, as well as fuel costs in port on an annual basis. And in doing so, it is necessary to look at the consumptions which fuel consumptions which the vessel produces through the operation of the main engines and the auxiliary engines. So and in order to do that, it's necessary to refer to the specific fuel consumptions of the engines, as well as load factors of the engines for either at sea or at port, time, duration of operation, and the number of trips per year, sailing distance per trip, the service speed, time in port, the main engine power, the maximum continuous rating. Okay, is a percentage. The ME here will have to be, yes, the maximum continuous rating, and the load factor accounts for the percentage of the maximum continuous rating over a certain period of time. And of course, since we're dealing with fuel costs, we will have to multiply the consumption of the main engine in terms of the fuel costs of the main engine, the unit price of the fuel of the main engine, and for the fuel costs of the fuel which is used by the auxiliary engines respectively. Okay. Now, with regard to the external cost methodology, the external cost factors for freight services, excluding air pollution and climate change, which we will come into in a minute, we have some valuable data which can be utilized, offered to us by the impact study, and refers to road services as well as the source sea shipping service, or and the distinctions between the road leg and the road service. The distinction is depends on the type of road we're moving on. In other words, whether it's a motorway or whether it combines some urban characteristics and the road leg of the SS of the short sea shipping service definitely has some characteristics of that nature, as opposed to the road service along the motorway between Athens and Thessaloniki. So we have different cost factors with regard to congestion, accidents, noise, nature and landscape, soil and water, and the upstream and downstream processes. As we can see, the sea leg more or less it has zero congestion costs, accident costs, noise costs, some impact on nature and landscape, probably due with the fact that it has to connect to some ports as well. Soil and water, yes. Water, we know there is a problem with shipping, any pollution with regard to water, and upstream and downstream processes in all purposes near zero. Now, the air pollution cost can be approached again with to addressing the various factors with a greater detail, and the activity methodology again is suitable here, where everything which was valid for calculating the fuel consumption and the fuel costs will have to be repeated, with the only exception that instead of talking in terms of specific fuel consumption of main engine and auxiliary engines, we have to talk in terms of emission factor. Okay, so that will give us a very good estimation of the air pollution cost when we split the operation of the RoRo during the sea, at sea and in port, because the impact of air pollution differs whether you're operating at sea. Of course, this is the case where we operate near the coast, but it's definitely even that is definitely different to the operation of the ship while it is in port, as the impact is much higher due to population of ports. Some ports like Thessaloniki and Piraeus, but in this case Thessaloniki, are port cities, and the impact of air pollution is much higher. Sorry. So, as we had to refer to the fuel price before, in this case we have to refer to external cost factors of air pollutants, and this is taken into account when we do an activity-based methodology for evaluating the air pollution cost of the RoRo vessel. Now, in order to be able to use the previous equations, whether those were relating to fuel costs or to air pollution costs, we have to assume the load factors of the engines, percentage of the time for which they operate at these load factors, which are not constant. It depends whether you are at sea or in port, and whether when it comes to tracks as well, whether you operate along the motorway or you're at the national road, or some road which involves some urban characteristics, therefore you will have to slow down and the engine load factor will have to be lower. Okay, so we have load factors as well, which engine load factors which have to address the case of trucks and follow the same approach as we did in estimating fuel consumption and air pollution from trucks, as we did for the RoRo vessel. We do need also, as it has been already mentioned, to have some information with regard to emission factors. Now, for air pollution purposes, the most significant emissions are those relating to sulfur dioxide, particulate matter, and nitrogen oxides. These are definitely air pollutants. They have chiefly local effects or regional even effects, depending on prevailing circumstances, weather conditions, etc. But they are clearly distinguishable from CO2, which is climate change, is a greenhouse gas, and definitely impacts upon the climate change, thermal and global warming, thermal pollutant of a different scale. Now, we have to make some assumptions with regard to the fuel content, the sulfur content of fuel by mass, and as you can see, it is assumed that with regard to the raw emission factors, the use of a 2.7% sulfur content fuel is assumed, mainly by the main engines, as well as 0.1% fuel, 0.1% sulfur fuel, which is used by the diesel generators. A couple of points for this assumption. First of all, a ro-ro vessel is a freight vessel, and in that sense does not have to apply with the European directive of using much lower desulfurized fuel, and also the Mediterranean is a non-ENCA area, therefore maximum limits of sulfur apply. They apply globally, and that is 3.5%. Currently limits are 3.5%. So an assumption of 2.7% is more or less accepted as being the average sulfur content for non-controlled areas or operations, as it is the case for the ro-ro operation within the Mediterranean. However, with regard to the sulfur content of distillates, there is also compliance to be made with the European directive, and that limits us on 0.1% sulfur. Now, when it comes to the track emission factors, the picture is completely different, because we are down to levels of sulfur content of 10 parts per million, and that corresponds to 0.001% by mass. Therefore, the exhaust emission factors of sulfur dioxide and also of particular matter are very low, taking into account, of course, that the SO2 emissions are a function of the sulfur content of fuel, but also a great part of particular matter is connected to sulfides, and that will lead an improved quality fuel in terms of sulfur content, will lead to substantial reduction of PM of particular matter. Now, with regard to NOx, we have to also cater for the fact that a lot of track engines are catalytically controlled now in order to take account of the nitrogen oxides, and they're very low as well. Okay, for the qualities of fuel used either by the vessel or the trucks, the emission factors in terms of carbon dioxide are as quoted here. So we can make use of these emission factors, which are given to us by literature, which is circulating around in a lot of studies and are valuable in enabling us to proceed with this type of evaluation. Okay, now with regard to external costs, again we need external cost factors, and as we can see, we can distinguish between the external damage offered by emissions of SO2, NOx, PM and CO2 in rural areas and at sea, and we consider them to be identical, which is a very good approximation. Near the coast, the case it is that you can equate. It is often suggested by various studies that you can equate the external cost factors to those over rural areas, and it is necessary, however, cater for the fact that we will have to have different external cost factors of emissions for damages which occur during the operation through an urban motorway or urban areas, that is to do with the truck operation as well as in port cities. Okay, so this is very, very important. Okay, as we can see, and as expected, the urban motorway and port city external cost factors are higher, but especially with regard to SO2 and particular matter, but when it comes to NOx and CO2, there's no change, in any case significant change, but in this case it is assumed that they're more or less equal. Now, with regard to the analysis of the annual internal costs of the road service, that is the road freight between Athens and Thessalonica, we can see how the breakdown of costs is. Something like 50% of the overall cost on an annual basis is related to fuel. In this case it says is 48.4% and accounts for 35 million euro. Is a high, really, fuel expenditure, but you will expect that. For the daily operation of 200 trucks going up and down throughout a year, or to be more exact, during 335 days in a year. And we'll see how The rest relates to that. Tolling is the next higher cost, followed by tires. Okay, we have a lot of kilometers there, so we will expect that. Have frequent tires changes, and then we have fixed costs as well. And we'll see how the fixed costs break down. Okay, and the biggest part of it is to do with the expenditure involving the drivers. It is 5.5 million euro a year. That 5 million euro is part of the 7.98 from the fixed cost. Quite a bigger expenditure. The annual internal costs of the SS service this is a breakdown. The overall costs. Fuel cost is again, it takes a very big chunk of the overall cost, but more or less very close to the tolling and port cost. Now, you remember with regard to the SSS short sea shipping service, we have a combined. We have a service which is composed by the road leg and the sea leg, so we have tolling and ports which account for 37.7% of the overall cost of the service on an annual basis, and that is nearly 21 million euros. But it is a lot of it related to the fact that we do have a lot of tolls as well to accommodate over 200 trucks going through on a daily basis, or 50 trucks and 4 round trips daily along the Athens to Lavrio connection, plus the port use as well. And the fixed costs as well with regard to the trucks and the vessels. And the vessel, we can see again that the biggest portion of it is to do with the truck and the vessel itself. Trucks, in other words, purchase costs reported. Now, when we look at the annual externalities, negative externalities or external costs of the road service, in other words, the road connection between Athens and Thessaloniki again, we see that the highest chunk is relevant to congestion, very high. Then we have all the other costs, which include air pollution and climate change, as well as natural landscape, soil and water, and up and downstream effects and accidents. Okay, with regard to the presence of accidents, it is the second highest of the individual damages which the service presents, and then we have air pollution and up and downstream effects. Okay, climate change at 6.7%, and so on. Now, with regard to the analysis of the annual external cost of the SSS service, we can see the breakdown here, and of course the C leg represents the highest portion of it. That's of the order of 65.7%, and of that 63.4% refers to air pollution. Very small contribution coming from climate change, and some minimal contribution coming from soil and water. Okay, we did assume that the sea leg service offers near zero damages with respect to all either external cost items. And the remaining part of the SSS service, in other words, apart from the leg, is the small road leg part between Athens and Lavrio, and we see that again congestion comes up as being the highest, and accidents follow. So things do not change significantly from the previous picture where we had the road service on its own with regard to what is the most damaging of all items, and the congestion seems to be the most damaging here as well, and everything else follows. It is interesting to see that air pollution is the third item of the road leg service, of the road leg component, and I think air pollution was also the case. Third item with regard to the road services. Sorry. Okay, so in absolute terms, because what we were looking at before, it was percentage shares, okay, plus the costs, individual costs. Here we can have a service comparison, cost comparison of the competing modes, and we can see that the road service has a higher total cost on an annual basis than the short sea shipping service. Okay. However, this is mainly due to having a lower internal rather than the externalities. In other words, what we're seeing here is that the short sea shipping service produces higher internal costs than the road alternative, and we have to bear in mind that this is mainly due to air pollution. Coming mostly from the SSS sea leg. as we can see in the breakdown, the SSS service on the right hand side of the graph, okay, where we have 19.8 million euro per year, the externalities cost, external costs for the sea leg, and 10.3 for the road leg, and both of them combined would give the 30.1 million euro per year, which is the external cost of the source ship. So this is interesting, but we can account for it in a minute. Now, as I said before, the Ro-Ro vessel will produce the same internal and external costs the internal and external costs of the SSS service will differ as a function of the utilization factor of the vessel. In other words, the base scenario we're looking at here is that the vessel will operate with 200 trucks per leg of the Ro-Ro service, but we can see how this will change if we increase or decrease the utilization factor. And what is important to see is that for the externalities of the SSS service to become equal to those of the road service, we will have to have a utilization factor of 320. Remember, the source sea shipping service had higher externalities than a road service, which were mainly attributed to air pollution. Okay, for this to be overcome, it would be necessary to increase the utilization factor or the loading factor of the Ro-Ro vessel from 200 trucks to 320 trucks. In other words, to move towards full occupancy, which is what we see here, nearly the 100%. Okay. Now, the internal costs are in favor of the source sea shipping service down to a utilization factor of just lower than 25%. Okay. It says there 74 trucks. When the Ro-Ro vessel carries 74 trucks, then it breaks. The internal costs of the two services are the same. An increase of utilization makes the source shipping service much better. In other words, cheaper in terms of internal cost. Therefore, the overall costs, in other words, external costs and internal costs considered together, we will see that the source shipping service will have to carry more than 153 trucks in order to offer an advantage to the road alternative in terms of internal and external costs. And that is a utilization factor of nearly 50%. Now, when we look at the raw vessel alone, we can see that things are a lot improved in favor of the raw service, as it will be necessary to carry only 177 trucks in order to be superior, up to 177 trucks in order to be, more, 177 trucks in order to be superior than the road service. And of course, as expected, the picture will be much more, it will be improved with regard to internal costs for even lower utilization factor numbers, as it is the case here. Only 45 trucks. Anything higher than 45 trucks will make the RoRo service better in terms of internal costs. Overall, it will be necessary to carry just over 25%. It will be necessary to carry more than 89 trucks, or something of the order of 25% utilization factor, in order to make the raw vessel alone superior to the road alternative. So we have a tabular presentation of the summary of results here. We can see which is the first cost item, second cost item for either service in terms of internal and external costs. For the 62.5% raw load factor or utilization factor, as it was found already, which constitutes the basis of our exercise, or the minimum raw load factor for SSS cost advantage, (23% in order to have superior performance by the short sea shipping service in terms of internal costs, 100% utilization factor for having superiority in terms of external costs, and 47.8% utilization factor for the overall cost advantage. Now, when we take away the road leg, as it was shown in the previous graphs, internal costs can be, the superiority of the service can be attained at a much lower utilization factors of the RoRo, or load factor of the RoRo, 14.1 for internal costs, for the external costs 55.3, and for the total costs down at 27.8%. Conclusions. The short sea shipping service competitiveness vis-à-vis road transport is improved through its application as a point-to-point substitute rather than a complement to road transport. Okay, this is important, because short sea shipping service is often involves a small often involves a small road service, or even be a rail component. But in any case, it's better if we have an alternative, a modal shift over the same origin and destination points of the freight. In that case, it will be a better, it will offer a better option. Increasing the vessel's capacity utilization, or striving for a higher modal shift of freight, will improve the performance of the short-sea shipping service, and we know that, and that's why we do strive for increasing the modal shift of freight in order to make the sea services more competitive as opposed to road freight. However, it is important to note that the use of ultra-low sulfur marine fuels will improve the performance of the sea service with regard to the negative externalities of air pollution. And although this will undoubtedly have an effect on the internal costs, as the desulfurized marine fuels are more expensive than the marine fuels of sulfur content, which reach on average 2.7%. But even if you were to go to ultra low sulfurs, sulfur fuels, in other words, coming very close to the specification of the road fuel, then the premium will have to be very high. However, if we don't really have to go so near the quality of the auto diesel, let's say, we do expect the impact upon internal costs to be not so great, okay, not so significant. This is encouraging because at this very moment the price of fuel is very low, and it does affect also the price of desulfurized marine fuels. So we are not so expensive as they used to be a year ago. Although all this exercise was based on fuel prices which were more relevant to the prices which we observed more than a year ago, roughly 1.5 years, 2 years ago. So in terms of internal costs, and specifically fuel costs, we do expect the results to be lower, the levels to be lower, but we don't expect any differences, any difference in the comparison of fuel costs, because when the marine fuel costs come down, so the same is the case for auto diesels. We don't expect the difference to be very the comparison between the fuel costs of the two services to be affected. Okay, thank you very much. I look forward to your questions. Thank you.